Now we'll discuss another important topic in our Vedic maths, that is digital sum. What do you mean by digital sum? And what are the application of this digital sum? Now we will see here. For example, suppose 43, a number is there, and if you want the digital sum of this number, digital sum is nothing but simply the sum of the digits in a number until you get a single digit. Now what is the digital sum of 43? It's simply 4 plus 3 is how much? 7. So 7 is my digital sum. Digital sum of the 43 number is 7. 54. What is the digital sum of 54? 5 plus 4, 9. Suppose, what is the digital sum of 3, 2, 4? Okay. So 3 plus 2 plus 4. 3 plus 2, 5. 5 plus 4, 9. Simply add the digits in the given number. That is the digital sum. Suppose 78. I want the digital sum of 78. What is 7 plus 8? 15. But one important point is the digital sum can never be in a double digit number. So what you need to do? Again, add these two digits. That is 1 plus 5. How much? 6. So the digital sum of 78 is how much? 6. 7, 8, 5, 7, 8, 9. What is the digital sum? 5 plus 7 plus 8 plus 9. 5 plus 7, 12, 12 plus 8, 20, 20 plus 9, 29. Means again 2 plus 9, 11. Again 1 plus 1, 2. So like that you have to go. See, if I add all the digits, I got 29 here. I got 29. Even the 29 is not the digital sum. Again make the sum of 2 and 9. So what is 2 and 9? It is 11. So again 11 is not the digital sum. So again 1 plus 1, 2. So finally, what is your answer? Digital sum of 5, 7, 8, 9 is 2. Suppose if I ask you, I want the digital sum of say 5, 4, 3, 9, 9. I want the digital sum of 5, 4, 3, 9, 9. So what is the answer? 5 plus 4, 9, 9 plus 3, 12, 12 plus 9, 21, 21 plus 9, 30. 30 means again 3 plus 0, 3. Like that you can write. Suppose 39, the digital sum. This time don't do 3 plus 9 and like that. See, in our digital sum, the 9 can be replaced by 0 when you are adding only. In our digital sum, 9s can be ignored, or the sum of the digits that are, or the digits which are adding up to 9s also we can ignore. For example, in 39 I can ignore 9, no need of adding. So simply what is the digital sum? 3 is my digital sum. Suppose 4, 5, 9, 2. I want the digital sum. I can ignore the 9. What is 4 plus 5? 9. Even the digits adding up to 9 also you can ignore. So what is the remaining? 2. So 2 is my digital sum. Suppose 5, 3, 4, 7, 6, 2. So 5, 3, 4, 7, 6, 2, 5. So I want the digital sum. So simply there are no 9s to ignore, but even though there are the digits which are adding up to 9. 5 plus 4, 9. Ignore. 3 plus 6, 9. Ignore. 7 plus 2, 9. Ignore. So what is the finally? 5. So my digital sum is how much? 5. Digital sum of 5, 4, 3, 7, 2, 5 is 5. Suppose 777, 222. What is the digital sum? 7, 2, ignore. 7, 2, ignore. 7, 2, ignore. So finally the digital sum is 0. But it is wrong. You cannot have a digital sum as 0. Think practically. Whenever you I think logically also, whenever you add some digits, how can you get the digital sum as 0? You will never get it. So if you are all the digits are ignored when you are doing the digital sum without any having without leaving a single digit, if all the digits are ignored which are adding up to 9, the digital sum is simply 9. The digital sum is 9. Now you may ask me, so what are the advantages of this digital sum? Now let us see the applications of this digital sum. This digital sum, it is very useful in the application of checking the answers, cross-checking the answers which you calculated already. For example, suppose 324, 324 plus 457. I want to add these two numbers. So 3 plus 4, 7, 7 but 8, 1, 781, I got the answer. I want to check whether it is correct or not, but in a faster way. Simply, if I want to do in a faster way, I will do one thing. So I will take the digital sum. 3 plus 2, 5, 5 plus 4, 9. So 9 is digital sum of this number. What is the digital sum of this number? 4, 5, 9 can be ignored. So 7. 9 plus 7 is how much? 9. We are doing the addition only, right? So I am adding the digital sum of the numbers. Okay, 9 plus 7 is 16. Again 1 plus 6 is 7. So I got the digital sum as 7 for my answer. Now cross check the answer which you got, whether you got the digital sum same or not. 8 and 1 both are ignored, so finally 7 is the digital sum which you got in the answer. If both the answers are matching, if both the digital sum of the numbers are matching, that is the two numbers sum as well as the answer, if they are matching, then your answer is correct. But if they are not matching, your answer is 100% wrong. One more example. 5243 plus 7896. I want to add immediately first. I want to check. Anyhow, 5 plus 4 we can ignore. 2 plus 3 is 5. So 9 we can ignore. 7, 8, 15. 15, 6, 21. 2 plus 1, 3. 5 plus 3, 8. So I should have the digital sum as 8. Let us see. 12 but 13, 0 but 1, 3 but 3 only, 9. So 9 can be ignored. So 4 plus 4, 8. I got the same digital sum. So my answer is right. Understand? One more example. Suppose 748 plus say 397. I want to add this one. 10 but 4 5 1045. I got 1045. Now I want to cross check this one. Okay, 7 4 11 11 8 19. 19 means the digital sum is 1. Okay, here 9 you can ignore. 3 plus 7 10, again 1. 1 plus 1 is how much? 2. So I should have the digital sum as 2. Now check. 1 4 5, 1 plus 0 0, 1 plus 0 1, 1 plus 4 5, 5 plus 5 10. 10 means 1 plus 0 1. It is not matching with the digital sum. I got the digital sum as 1, but actually you have to get it as 2. So my answer is wrong. So what is the actual answer? You can cross check like that. So 7 plus 3 10 but 11, 3 but 4 5, double 1 4 5 is my, okay, now what is the digital sum? 2. Now it is matching. If remember one thing, if the digital sum is matching for your answer, it is 100. Okay, we can't say it is 100% correct. But if it is not matching with the digital sum, if your answer is not matching with the digital sum, you can say your answer is 100% wrong. Let us see how. For example, now we'll see that application in the subtractions as well as multiplications. There you can understand very clearly. Now let us take some examples. Say 43 minus 18. I want to check in the subtractions this time. 4 minus 1 is 3 but 2. 3 plus 2 is 5. So 25 is my answer. What is the digital sum here? 7 and here 9. 7 minus 9. Is it possible? Remember one thing. Whenever if you are getting the digital sums like this 7 minus 9, it's not subtractable. But what you need to do? You simply do one thing. Here, how much you are getting? What is the difference you are getting? Minus 2. Yes or no? So for minus 2, add 9 again. What is minus 2 plus 9? 7. So your answer should have the digital sum as 7. So 2 plus 5 is 7. Getting same, right? Whenever you are getting the negative, simply add 9 to it. It will turn into the positive. So that digital sum should match with the answer. We'll take one more example. So 5 3 2 4 6 8 minus 2 7 9 5 3 8. I want the digital sum. I want to check the answer. 3 but 2 2 3 6 but 5 2 plus 1 3 but 2 5 9 but 2 3 but 2, so 3 but 3 0. Now let us check the cross check the answer. 5 4 you can cross check. 6 3 leave. 2 8 1. Now 9 9 5 3 8 8 is 16. 1 plus 6 7. 1 and 6 1 and 7. It is minus 6. minus 6, so I am getting the minus, so add 9 here, how much will you get? 3. So my answer my answer's digital sum should be 3, otherwise it is wrong. Let us see. 9 ignore, so 2, 5, 2, which are summing up to 9, ignore, so 3 plus 0, 3, so finally it is matching, so my answer is right. Okay, like that even we can discuss or we can apply the digital sum in subtractions also. Now we'll apply this technique, digital sum technique, in multiplications, where it is very, very useful, right? Now let us apply the same digital sum technique to the multiplications to cross check the answers. For example, 2 8 is 16. Okay, I want to multiply these two. 6 4 3 8 11. So I got 1176 as my answer. So I want to cross check whether my answer is right or wrong. Now immediately check. 4 to 42, digital sum is 6. Okay, 28, digital sum is 1. So 6, what is it you are doing here? Multiplication. So 6 into 1 is 6. That means your digital sum should be 6, otherwise it is wrong. Your answer digital sum. So anyhow, 7 2, you can cancel. It is by because it is adding up to 9. So 6. Finally 6 is my digital sum. It is matching. So my answer is right. Let us take an example. 543 into 287. I want to multiply this one. 30. Right. So 543 into 287, I got this much answer. I want to check whether my answer is right or not. Let us see the same way. So 5, okay, 5 and 4 ignore, 3, 2 and 7 ignore. Why? Because they are adding up to 9s, right? So I am ignoring. 8, so 3 into 8, 24, that is 2 plus 4, 6. So I got the digital sum as 6. Let us see. So 5 and 4 you can ignore, 8 and 1 also you can ignore. Why? Because they are adding up to 9s. Now remaining is 15. 1 plus 5 is 6. Yes, it is matching. But you tell me one example. Suppose if I put here like this, 5 and 1, even I am getting the same digital sum. Yes or no? Yes, 5 plus 1 is 6, but before answer it is 15. Now this it is 51, even though the digital sum is matching. But is it right answer? No, it is wrong answer. It is a wrong answer. What is the right answer? 155841. This is the right answer. That means why I did like this. See, if the answer is getting the same digital sum, I cannot assure you 100% accuracy. But if you are not getting the same digital sum, yes, it is 100% wrong. But if you are not if you are getting the if you are getting the same digital sum, maybe, may not be. Sometimes what happen like this, mistakes will happen. So I cannot assure you 100% every time 100% accuracy, but mostly 99% I can say you will get the right answer only. You can get that confidence. Yes, my answer is right. If you are getting the same digital sum even in the answer also. Even the same thing you can apply for the division also. Just by applying the rule of what? Dividend equal to quotient into divisor plus remainder. Okay, you can apply the same thing here in the digital sum to get the to cross check the even divisions also. But remember one important point I want to tell you. One important point: digital sum is not applicable to approximate values. Digital sum is not applicable to approximate values. This point you need to remember. So whenever if you are doing some approximation values and if you are going for the digital sum, we cannot assure the answer. Why? Because see, suppose if I am doing some 2.9 into 3. So what is the digital sum for this one? 2.9 into 3 is 87. But if I round up this 2.9 to 3, and 3 into 3 is how much? 9. Okay, what is the decimal sum of 87 here? 87, 15, 1 plus 5, 6. What is the decimal sum of 9 here? 9 only. 9 and 6, are they both same? No, they are not the same. That's why decimal sum is not applicable for the approximate values or approximate calculations. So please keep in the mind and apply this method in your examinations. It will be very easy for cross-checking the answers. Right? So let us go for the next topic in our Vedic maths. Friends, now we will discuss some faster techniques in our Vedic maths for the percentages, how to calculate the percentages. As you already know, what is a percentage? For example, percentage is nothing but what? By 100. Yes or no? Percent means for every 100. For example, if I want 40% of say 400, 40% of 400. 40% of 400 means what? What you need to do for every 100? What is the value of 40% for every 100? So that means 40% means 40 by 100 into 400. Yes or no? Like this we will do. Zeros will be cancelled. 44 is 160. Yes or no? But there are some techniques where you can easily apply within a few steps. What? Let us take. Suppose I want the 30% of say 4,000. 30% of 4,000. Going for this calculation, apart from going this for calculation, you better do directly like this. What is 3 into 4? 12. And how many zeros are there? 3 and 1, 4. That means I am multiplying directly. 30 into 4,000. I am multiplying directly. Since both the numbers are easy, what I am doing? I am simply putting 3 into 4, 12. And how many zeros are here? 1 and here 3. 1 plus 3, 4. So add 4 zeros. I am directly multiplying. And directly multiplying 30 into 4,000. I got 1,20,000. But here what it is? Percent. Percent means by 100. So if I divide this number by 100, what I will do? I will just put a decimal point after 2 digits from right. This will be my answer. So 30% of 4,000 is 1,200. Similarly, say some 60% of say 35,000 I need. Sorry, 3,500. So 60% of 3,500. How will you calculate? You simply do one thing. 35 6 times. How much 35 6 times? 180 plus 30, 210. How many zeros? 3 zeros. So put a decimal point after 2 digits from right. That is 2,100 will be my answer. Simply, no need of using this much big formula. Understand? Suppose if the numbers, if at least one of the number is tough, you can go like that. For example, I want the say some 70% of 3800. Here one number is little tough and one number is easy. So you can directly go for the multiplication. 7 into 38 you do. 38 sevens. How much will you get? 210 plus 56. 266. So 266, how many zeros? 3 zeros. Put a decimal point after 2 digits from right. So your answer is 2660. One more example. I want some 63% of 800. I want 63% of 800. See here. Here 800 is easy one and 63 is little tougher one. So even one number is tough and one number is easy, you can directly go for the multiplication. 63 8 times. 480 plus 24. 480 plus 24 is how much? 504. 2 zeros at the end. Put a decimal point after 2 digits from right. This will be your answer. Directly you can say 504. And say one more example. Suppose I need some 80% of 7953. I need 80% of 7953. How will you do this one? Even this time also I will suggest the same thing. Multiply the entire number with 8. How will you get? So you can directly go. It is okay, 24 to 40 to 42, 72 plus 4 76, 56 plus 7 63. So 63624 I got. So 8, okay, and 0 at the end. 80 into 7953 is 63624. Now put a decimal point after 2 digits from right. So this will be your answer. Yes or no? 6362.4. Once again I repeat, directly multiply 7953 into 8. How will you multiply 7953 into 8? You can go in the mind. 8 7 is 56. 56 means in which place it is? Thousands. So 56,000. 56,000 plus 7,200. 56,000 plus 7,200 is how much? 63,200. 63,200 plus 400. 63,600. 63,600. 63,600 and 600 plus 24. 6,624. Even like that you can calculate in the mind. So what is your answer? 6362.4. So like this, even the calculations of percentages will become easy when you are dealing with the shorter, faster techniques of Vedic maths if you apply. Suppose one more example. Let us take 37% of sum 4,800. Here also multiply simply 37 and 48 fastly. 37 into 48 I want to multiply. 7 is a 56. Fine. Apply vertically crosswise fastly. So 24 plus 5 29. 29 plus 28 it is 57. 57 and 3 4s are 12. 5 will be carrying. 12 plus 5 17. So I got 1776. So 1776, 2 zeros afterwards. After the, so what you need to do? Simply, since it is how much? Percentage means put a decimal point after 2 digits from right. This will be your answer. So 37% of 4,800 is how much? 1776. Like this, even you calculate percentage values in a faster way by applying the multiplication techniques of Vedic maths.